Hello everyone, I'm Frank, and welcome to Frank Puzzles. And this is today's hard level difficulty puzzle. And it's called Lupin's Loop 2 Space Invasion by Baron. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have digits separated by a white crop key dot are consecutive. So for example, if this were say a 6, this would have to be a 5 or a 7 here, because the only digits which are consecutive with 6 are 5 and 7. And these digits must be consecutive because there's a white dot between them. Okay, so this is the gist of this puzzle. We need to draw a single route that travels orthogonally from cell to cell, never branching, crossing, or overlapping, and eventually closes into a loop. So what does it mean to travel orthogonally? That means it can only go horizontally or vertically. It can't go diagonally. So what's an example loop? It could be something, whoops, edges only here. Could be something along the lines of this, right? It can only go horizontally or vertically. It cannot cross itself or overlap, and eventually closes into a loop. So this is an example of a valid loop here. The loop must pass through every planet. So this is not valid because it has to pass through every planet. Thick black borders represent black holes that the route cannot cross. So I naturally did that because I didn't want to, I don't know, it just felt like barriers. But these are black holes which the route cannot cross. A digit in a satellite, I'm assuming these are satellites, equals the number of loop cells in the 3x3 box centered on that cell. So I assume this is the satellite, and that would then mean that this would have to be 5, because the loop enters only 5 cells in the 3x3 box centered on that cell. This would be also 5, because there are 5 digits, or 5 cells, which the loop enters in this 3x3 box centered on that cell. Okay. Along the loop, one parity forces the route to turn, which is make a 90-degree angle, while the other forces it to continue straight, making a 180-degree angle. So we have 90-degree and 180-degree angle. It is up to the solver to determine which parity corresponds to which behavior. So you have odd and even parity. One parity forces the route to turn, which is make a 90-degree angle, while the other one forces it to continue straight, which is making a 180-degree angle. So the solver has to determine which parity is which parity forces which behavior. Any two cells that are adjacent along the loop must contain non-consecutive digits. Okay. The only case where consecutive digits may appear along the loop is if the loop passes through a white Kropke dot. Huh. Okay. So, any two cells that are adjacent along the loop must contain non-consecutive digits. So but the thing is, if the loop crosses through the white Kropke dot, they can't. That's the only case where consecutive digits may appear on the loop. So this is still valid as a potential loop because it passes through the white crop key dot. But for example, this digit could not be, these digits could not be 4 or 6 because they're consecutive with the 5 and there's no white crop key dot in between these. Interesting. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Every single digit in row 9 is on the loop. And we know that to enter row 9, so it had one thing is this cell has to always be entered and then turned into. This cell must be always entered and then turned into. For this to form a loop, what that means, it can't be these are the same, right? You're going to have one turn go here, and then it's going to turn to get exit out. Then you have to have another turn coming in, and then another turn exiting out. So that means total in row 9, we need 4 cells that will turn the loop, and 5 cells that will go straight. Well, that means the turns have to be on even digits, and going straight must be on odd digits. We can't turn, because then these would all be straight, and that's not going to be able to turn them. So this must go straight here, at least. So that must go straight, and this must go straight. And we have to have either a pair, 2 blue here, 2 blue here, 2 blue here, or 2 blue here. We're not sure where. So that they can turn up correctly. So this will necessarily go that way. The loop must go through these 3 cells. So that means this cell has to be turning, because it can't go down here. Actually, that's not true. Ooh. We do not have a guarantee that these are both red. You could have blue here and this be all the way red here, and then that's blue. Huh. Now that's interesting. Okay, I didn't think about that. So the blues are even, obviously. So this is, okay, can we ever go this way? I guess. Right? What happens if we have a turn here and a turn here? Okay, so say we had this blue, these are both blue here, so then this turns going that way. So these would have to both be blue to turn. This would obviously go straight, this would go straight. We don't know what that is. So this would go straight there. This would have to go straight here, but then this has to turn, because otherwise that's not going to work. So then this must be blue, but this would have to turn. So then this must be blue, and that's too many blues in box 7 because the blues are even. Therefore, we know this can't be blue here. So this is guaranteed to be red, which means this must continue on this way. So to go through this planet, it can't connect to this. It has to go here. Well, this is turning. This is turning. This is turning, and then this must turn. It cannot go this way, because if it goes this way, it would have to turn again. And that's too many turns, because that would be too many blues in box 7. So it must go this way, which means the rest of the box is red. So these are all red, which means this goes this way. This turns there, and it must go straight this way. That means this, to enter this planet, it has to enter in this way and then turn that way. So this is blue. What happens if this is blue? If this is blue, we have a blue here for this to turn. That means this goes this way. It must go straight. That must go straight there. So then this goes straight. That turns there. And then this would have to go straight. So that is... Okay, so... How does that work? Then this would have to go that way. This goes here, turns. This goes straight. But the problem is this would have to turn, and therefore would be blue, which is impossible. So we've shown that this cannot be blue either. This has to be red. So that's what I was intuiting already. Okay. So that means for this loop has to exit out either this way or this way. If it exits out this way, the problem is it can't go back to here. So say we exit out that way. If we exit out this way, the problem is how does this loop go to connect to this planet? It can't, because then it would have to either branch here. Yeah, it would have to basically branch here, and that's not allowed. So we cannot go that way, which means this has to go out this way and connect there. Because we can't, this has to exit out somehow. We can't go like that, because then this also would have the same problem of entering in here and not being able to connect to the end of the loop here. So this has to go this way, which means this is red. This has to turn and is blue. This must go straight and is red. So it has to go this way, which means this has to go here, which means it must go through here as the loop. This is turning, that's blue. We cannot turn any more in column 9 because we don't have any more blues. So this must continue on until this planet here. That means this must turn. This has to go straight, and this has to turn. These go straight, and these have to turn. So then these are both blue. These have to be both red because of the turning here. So it has to enter here. This goes straight. So this must be straight also. And it either turns here or it turns here. We're not sure which. This turns, it cannot turn there, so it must turn down here, which means it connects to here. So then this is blue. We have blue, blue, red, red, blue, red. Don't know about these. If we turn, it must turn again. and that would be too many blues in box 9. So this can't turn, it's red, which means we have a guaranteed blue here. So one of these is turning that way. So we have a guaranteed thing going that way. This must go this way. And then one of these is red and one of these is blue. One of these is blue. We're not sure which. Oh, these are consecutive, so this must be blue here. Which means it turns. It cannot turn on here, so it must turn here. Hmm. Can this be the one that's turning? The answer is no. If it turns here, I guess it could. No. So say this turns. If it turns here, it goes here. Obviously, it has to continue on the loop, so it has to turn again there. And then it goes that way. But then the problem is we have these are both blue. And there's 4 blues in box 8, so therefore this goes straight, which means it goes straight to nothing to connect as the loop. So that does not work. So this cannot be blue. This must be red, which makes this blue here. So this goes that way. This goes that way. This is eventually going to have to turn. So one of these cannot turn, which means both of them can't turn. So they both have to go straight. So we have to go straight here, straight here. These are both red. We have a red and a blue here. That means remaining in box 9, which means the remaining digit is blue here. And this must be blue, so it must turn. Because this cannot connect to here. Because then that would be too small of a loop. So this goes there, this goes straight, this goes straight. So these are both red. This is red. We have all the reds and blues found in row 7. This is a blue-red pair. We don't know which is which. This has to turn, and it cannot connect that way, so it must turn there. We have 4 blues in row 6, so the rest cannot be blues. So they must be red, which means this goes straight. This must turn there, and it must turn that way. So this goes straight, that's fine. One of these is going to have to turn. And it can't, if this is the one that turns, the problem is, yeah. This is not, cannot connect to here. So this part is going to eventually have to turn, which means this must be going straight because we have 3 blues already in row 5. So this must go straight, which means this turns here. So that turns there. We have one more turn here. So this is even. We already have 7 cells that are in the 3x3 area around it. So this must be 8 here, which means one of these is turning. We have then 4 evens in box 5. So this cannot turn. So this must be red. That means this has to turn here, because otherwise this is going to be problematic here. Because if it doesn't turn here, it's got to turn there, and then that's going to form a closed loop, which has to branch to connect to this part. So that's not going to work. So then this must go turn. Therefore, this goes this way. We cannot connect again, so this must be blue, which means this goes that way. We have 4 blues in box 4, so that's why this has to be red, which means this is straight. This has to be red here. This must have 8 in it. It cannot go this way, specifically. So it has to go straight to here for this to be this 8 sat on the satellite to be correct. Because you can't enter and then not exit back out somewhere. So this has to be red, which makes this blue. That turns. So that goes that way. We have 4 blues in row 4. So this is red. This cannot be blue. If this is blue, it has to then enter in and then exit back out that way and then turn again. But there's too many turns already accounted for. There's too many blues in column 4 already. So this must be red and it must go straight through for that planet. We have 4 blues in column 1, so the rest are red. One of these is going to have to turn. Actually, we have 5 reds in column 3, so the rest are all blues. Interesting. So that means this turns, and it cannot connect that way. So this must turn here, and must turn there. And this must connect. And then this is then a blue. We have 4 blues in box 1, so the rest are red. These could connect. Don't, you know. So these are either going to connect here or are going to connect here. So what happens if we try connecting this way? If we try connecting that way, this is blue. We have blue, blue, blue there. Okay, so in column 5, to connect to here, you're going to have to either have blue here or blue here, which means the remaining digit or the remaining cells have to be red. So this is guaranteed to be red, which means it goes across there. This has 1, 2, 3, 4, 5, 6, 7 cells there. This either continues red here and goes blue. Huh. So, one thing we know is this can never enter here. Well, technically it could. We have 3 blues already in column 4. So this cannot be blue and then blue to turn twice. So this must be then going straight. as red, and this is a blue. So this goes straight to connect there, which means this is blue. One of these digits is going to be even, and one is odd, because they're both consecutive. Which means we have 5 odds accounted for in row 3, so this can't be odd, it's even. We have 4 evens in column 5, so this can't be even, that's odd. So one of these two is even. It could go this way. So if this turns, it has to be red here, and it goes straight through. Which means then it would have to go essentially back this way to connect. If it goes here, that means it's going straight. We have 5 odds in row 1. It would have to turn here. So either way, this is guaranteed to be going that way. And whether it goes that way and then turns here, this is going to be turning. Or if it goes straight there and then turns, this is going to be turning. So this is guaranteed to turn. So can we turn from here? So if we have red, this is blue, 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 blue. That could work. Okay. So can we go this route is what I'm thinking of. So the route is either go here, and then it has to turn back here. This has to connect that way. That would have to go that way and then connect. Does that work? That would then be blue. You'd have red here. These would both be red. You'd have to have red here. That's blue. And then this is blue. So that looks correct. So that is a potential. What happens if this is red? If we have red there, this is guaranteed to be blue. Can you go that way? Is kind of a question. No. So we cannot go this way because the problem is you'd have to turn here and you'd have to turn again here, so they would both be blues, but that's not possible because they're consecutive. So if we go that route, then this would have to turn. This would go that way. You'd have to go there. This would be blue and blue. This would be red. This would have to be blue. And we have too many blues in box 3 because it would have to turn here. It would have to either turn here and then turn again. That's 5 blues. Or turn here and turn again, which is 5 blues. So therefore, this cannot go straight through. This then has to turn. So this is blue, which makes this red. Goes straight through there then. Then it turns again, so that's blue, which means it goes there. This has to orthogonally connect because we have to go through every planet. And this is the only, these are the only pass through. So this turns here, it's blue, this is red. That makes that blue, which means that turns again. You can't have turn, turn, turn. Because that would be too many blues, so this must go straight. Which means that turns there, and then that's fine, so that goes straight there. And we have the loop. We have we have 5 reds in row 2, so this must be blue. We have 4 blues in box 3, so this must be red, and this is consecutive. We have 4 blues in column 7, so this must be red, which makes this a blue there. Okay, and then we just have to fill this out with the thing that no 2 cells along the loop must contain, any 2 cells that are adjacent must contain non-consecutive digits, unless they are going through the Kropke dots. Okay. Hmm. 8 can't be here. Can't be 6 because that's consecutive with 7. So this is 2 or 4. These digits are consecutive. Okay. This is 2, 4, or 6. 7 is consecutive with 6 or 8. Remaining digits in column 3 that are even, we are guaranteed 6. This digit is the same as that. So this is 2 or 4. So we'll mark that as A. That must be the same A there, which means A is one of those 2. A cannot be here. A is one of these 2. We have 2, 4, 6, 8 here. This cannot be 7 because that's consecutive with either 6 or 8 here. This can't be 7 either. Oh, 7 can't be either of these because of 7 in the row. 7 cannot be either of these because that's consecutive with 8, and there's no white Kropke dot there, so this must be 7 there. That's kind of cool. So 7 can't be here, 7 can't be here. So 7 has to be one of these 2 digits. This cannot be a 6 here because that's consecutive with a 7. And there's no white Kropke dot here. So since this can't be 6 or 8, this can never be 7, which means this has to be 7 here. So this can't be 6 or 8, that's consecutive with 7. This must be 2 or 4 there. No 9 here in either of these cells, so where is the 9 in this box? It must be one of those 2. This is 1, 3, or 5. This has to be 2 or 4, which is consecutive with 1, 3, or 5 here. That means the only remaining digit in row 5 that's even must be a 6. So that's 6. Then we have 2, 4, or 8 here, 2, 4, 8 here. 9 has to be one of these 2. These are not consecutive. So this cannot be 3 here. Because if this were 3, that's consecutive with 2 or 4 here. So we have 1 or 5 there. We have 2, 4, or 6 here, 2, 4, or 6 there. Okay, so where is the... this is 8. Never mind. A has to be one of these 2. I don't know which. A cannot be here. So A is one of these three. These are all odd digits. Huh. Um... So this can't be 7 here. There's no 7 here. One of these three is a 7. No 7 here, so one of these three is a 7. Obviously, if this is 6, then neither of these can be 7 here, so 7 would have to be there. That doesn't really help us much. A cannot be here. A cannot be here, so one of these two is A. We don't know which. A is one of those three. A is one of these three. Oh, this is interesting. If this is 4, this has to be a 1. Ah. And therefore, this would be 2, which would force us to be 3 there. If this is 2, this would have to be 5. Because 2 and 1 are consecutive. 4 and 5 are consecutive. So if this is 2, that's 5, which would force us to be 4, which would again be only consecutive with 3. So either way, this is guaranteed to be a 3 here. Oh, it couldn't be 5 anyways because of the 6 there, but anyways, whatever. So this must be 1, 5, and 9 as possibilities here. So that means if this is 2, this is 5, which makes that 4, and that's consecutive. And if this is 4, this is 1, which makes that 2, and those two are consecutive. So these two digits are definitely consecutive. It's either 1, 2, or it's 4, 5. Oh, 9 cannot be here because 9 has to be one of these two digits. So where is 9 in box 6? It has to be here, which means this is 9, so this cannot be 8, which is consecutive with 9 because there's no white crocky dot. This is a 2, 4 pair, which means this cannot be A, and it has to be 8. Therefore, A has to be here, which means this can't be A. So this is a 2, 4. This is 2 or 4. This is 2 or 4. We'll make this B, I guess. This 2, 4 pair eliminates 2 and 4 in the rest of row 2. So this is 6 and 8. This is 6 and 8. We have a 6, 8 pair in column 3. That eliminates 6 and 8 in the rest of column 3. So this is B. We have A and B there. 8 is here. This must be a 1, 5 pair here, remaining in box 6. That eliminates 1, 5 in the rest of the box. So this becomes a 3, 9 pair here. That eliminates 3, 9 in the rest of that box. So this can't be 3. It must be 1 or 5. Well, 3 is consecutive with 4 and 2, so this can't be 2 or 4. Which means this must be... Hold up. How does that work? Huh. Because A can no longer be here, A can't be here, A has to be here. But that's consecutive with a 3 and a 9. Hmm. That's weird. Huh. Oh, no, 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 no. Okay. Yeah, so this has to be A. Right, so this is A, this is B, therefore this can't be 2 or 4, it's 6. 2 or 4 is consecutive with 3. So this can't be 3, that's 9, which makes that 3. There we go. So this is A, this is B, this is A, this is A. A cannot be here, A cannot be here, B is here, A is here. So no A here, no A here. So A has to be one of these two. We don't know which. But we know that's A, so this can't be A, so this must be A there. A then is one of those two. A has to be one of these two. We don't know which. And then it's one of these three. Right. Okay. So where's 8 in box 4? It has to be here. This is an A-B pair, so that's not really helpful to have A there. Oh, where's B in box 2? Cannot be here because it's guaranteed to be there. So B has to be there. We have B here, B here, B here. A has to be here again because it can't be here or here because of that A, and can't be here because of that A. So B cannot be here, cannot be here. That's A, so this must be B here. That eliminates B from being here, so B has to be there, which means B in box 4 has to be here. That leaves this as a 6. That leaves this as an 8. That makes that 6 there. This can't be 2 or 4, so it must be 6 there. That leaves this as 8, which means this has to be B over here. So this can't be B, this is A, which makes that B. So all the B's are done. All the A's, we still don't really know. We have a guaranteed 9 here. This can't be 9 because that's next to an 8 without a white crappy dot there. So this must be 9 there. This is A, this is B. This digit is next to both A and B on the loop. So it wouldn't be necessarily be next to 2 and 4, which means it cannot be 1, it cannot be 3, and it cannot be 5. Those are all consecutive with either 2 or 4. So this is 7 or 9 here. 6 is here, which is consecutive with both 7s. So neither of these can be 7, which means 7 has to be here. So that 7 eliminates 7 there, so that's 9. 5 cannot be here because it's consecutive with the 6. 7 eliminates 7 here, so that leaves a 7 in column 4 as there. We're guaranteed one of these is a 6. These have to be 1, 3, or 5 remaining. This digit cannot be 5. It's consecutive with a 6, but there's no white Kropki dot in between. This is 2 or 4. Oh, interesting. So these must be the same non-consecutive pairs, right? This is 2 and 5. If this is 2 and 5, this is 4 and 1. So let's mark the A with the Z to not be consecutive, and that's Y. So therefore, this must be Y here. So A and Z are not consecutive, and B and Y are not consecutive. So that means A and Y, maybe I should make it A and Z are consecutive. Okay. Yeah, A and Z are consecutive, B and Y are consecutive. I like that better. So B and Z cannot be consecutive. There's no white Kropki dot between. So A and Z are consecutive, and B and Y are consecutive. Okay. So A and Z are consecutive. So Z cannot be here, because that would be then consecutive with A here, and there's no white Kropki dot in between. And so Z cannot be here. Z has to be there. Z can no longer be here, cannot be here. Z cannot be here, because if this is Z, we know A is one of these two, and A and Z cannot be consecutive on the loop unless there's a white Kropki dot in between, which there isn't. And A is definitely one of these. So Z then has to be here. So this is Z, that's Z, that's Z. One of these two is Z. Don't know which. This can't be Z. If this is Z, we're guaranteed also to be next to an A. And again, A and Z are consecutive. So this can't be Z, which means Z has to be here. So this can't be Z. This must be Y, which means this can't be Y. That's Z as the 1, 5. So Z, that means one of these two is a Z. We don't know which. We have Z here, Z here. So one of these two is Z. So Z has to be one of those two. Z is one of these two here. Okay. Not too helpful. Y is here, Y is there. A, again, it has to be one of those two, has to be one of those two. This can't be 7. That's consecutive with a 6 in column 2. So where's the 7 in column 2? It has to be here. So that's 7. Where is 7 in row 8? Cannot be here because of 7 in the boxes. Can't be here because of 7 in the column. So 7 has to be there. Where is 7 in column 8 then? Alright, that was row 8. I may have said column 8 there. Cannot be here because of 7 in the row. So can't be here because of 7 in the boxes. So 7 has to be here, which is consecutive with 6 or 8 here, which means this cannot be A here. So A has to be here. That eliminates A from being there. So that's A. Okay. Um, This is 1, 3, or 5. Mm, 5 cannot be either of these. 9 cannot be either of these. So we have a guaranteed 9 in one of those two. 5 cannot be here. So this is 1, 3. And so this must be, the other digit here must be the y. Y cannot be here because of y in the column. Oh, y is 1, 5, though. So z could very well be a 5. So this is 1, 3, or 5 here. We have a guaranteed 5 here. That eliminates 5 in the rest of the column. 5 is one of those 3. This is 1 or 5. We have a 1, 5, 1, 5 pair now in column 4. That eliminates 1, 5, and 3 in the rest of the column. So this can't be 1, 3, or 5. It's 9. That eliminates 9 there. So this is 1 or 3. 9 is there. The remaining digits of row 9 are 1, 3, and 5. Okay. This cannot be 3. It's guaranteed to be next to a 2 or 4 here. So this has to be B next to Z. It cannot be Y. It's 1, 5, and this has to be Z. Which means this can't be Z here. Z eliminates Z here, which means this has to be Z here. That eliminates Z here, so this is Z. So this is guaranteed to be a Z. I think we have all the Z's accounted for, right? Yeah. We have a 1, 3, 5 triplet in row 8, which eliminates 1, 3, 5 in the rest of the row, so this can't be 1, 3, or 5. It's 9. Where is the 9 then in box 3? Can't be here because of 9 in the column. Can't be here because of 9 in the column, so it has to be here. That means 9 cannot be here or here. Where's 9 in box 2? It's there. And that gives us 8 9s, which means the last 9 has to be there. 9 is consecutive with 8, so this cannot be consecutive because there's no white dot in between, so this is 6, which makes that 8, which makes that 6, which makes that 8. Oh, we already had a 6 there. Anyways. Would have been able to get that almost immediately. This is A, which is 2 or 4. That leaves this as an 8. That leaves this as 6. This as 8. And the remaining digits are 2 or 4. This has to be 6 as the remaining even digits. That gives us all the 6s and 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same there. Okay. This is with 2 or 4. 6 cannot, has to, then this has to be not 5, 7, or 9. So this is 1 or 3. Which means this can't be 1, could be 1, 3, or 5. But 3 is consecutive with A, so this can't be 3. Which means this is 1 or 5 and cannot be Z, so this is Y. Which means, where's 3 in column 8? It must be here. That eliminates 3 from being here. So this is 1, 5, which cannot be Z, so that's Y. That means, where's the 3 in box 7? It has to be here. That eliminates 3 from being here, so this is Y. So we have Y here, A and Y are not consecutive. This is Z and Y here, so this must be 3 here. That means this has to be Y here, because we don't have any other digits. It's 1, 5. We have to have 7 in one of these, so 7 has to be here, which makes that 3. That's 3 in the corner. We celebrate because we're close to solving this. Kind of. Sort of. Where is... Okay. This could be... Actually, this could be y here. This cannot be 3, because again, 3 cannot be next to the A, because it's 2 or 4, and that's consecutive with 2 or 4, so 3 has to be here. Which means this can't be 3, so y has to be here. Which makes this a 3 here. So y has to be 1, which is consecutive with 2, so b is 2. So y, this is y also. All the y's are 1. All the z's are 5. The b's have to be 2. And the a's are 4. And this can't be 1 or 5, so this must be 3, which makes this a 1. Not too bad. Execution is probably on the hard scale. The logic behind this wasn't too bad, though. The execution, though, I do agree is hard. But it's not too bad as a puzzle. It was interesting, though. You basically were figuring out the logic of the loop before you were doing anything else in this puzzle. And then you were using the non-consecutive constraints to solve everything else. Which was actually really cool, actually. It was a very interesting approach to setting. Which was very... So it felt like sort of like 2 distinct puzzles here. It was like the puzzle to figure out what the loop was, and then the puzzle to figure out where each digit went. Which was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.